All right, so this video will be a review for the test tomorrow on sections 5.4 through 6.2. So first thing I'm going to ask you about is logs. Okay, so that's what we started with this week. We learned the change of base formula, and we can use it to solve different problems. So let's take a look at something like this. Okay, log base 5 of 21. Okay. Now on the calculator, we only have two bases you can type in directly. Is base 5 one of the bases you can type in? No. We can type base 10, and what's the other base? E. That's not either one of those. So first thing we have to do is rewrite that as a fraction so we can type it in. Do you remember how to use the change of base formula to rewrite it?
Would it be log 21 or log 5?
Yep, exactly. So type it in as log 21 over log 5 divided by log 5. And the answer is about 1.89. That's it. So that's using the change of base formula to evaluate or simplify an expression. Any question on that? All right. So next one, let's take a look at solving a log equation. All right. So let's solve one where the variable is in the base. Okay. So log base x of 6 equals 2. Okay, so that's an equation in log form because it has the word log in it. Do you remember the name of the other form we can change it to? We have log form and begins with an E. Exponential. Okay. When I have it in log form, what is the x called? That's your base. So when you write it as an exponential, that's going to be the base.
Oh wait, I feel like we did this wrong.
Logarithms always equal what kind of number?
Exponents.
Logarithms are always exponents. And the only thing we haven't used? 6. And now how would you solve that equation?
Take the square. Oh wait. I think you're right? Square root of x.
Take the square root
both sides.
Of both sides.
Yeah.
So x
The square root of 6.
is the square root of 6, which, if you wanted to know roughly what it is, it's about 2.45. And that's solving an equation where the variable is in the base. Any question on that? Okay, let's try the same type of thing, but now I'm going to put the variable as the argument. So let's do log base 3, and the variable is now in the argument, equals 5. Okay, you do the same thing as the last problem. Change it from log form to exponential. All right, so how would I change that to exponential? What would it look like? Yeah?
3 and then to the 5th equals x.
Yeah. Yeah, if it's not too big, you could, and that won't be, I mean, it's big, but it's not like in the billions. But yeah, you could do that out, and that would be your answer.
So would we put the answer like 253? I mean 243? Or would we just write that?
Is that what it comes out to? 3 to the 5th, 243? The directions would say either expand out the exponent, or you can leave your answer as an exponent.
Okay.
So whatever the directions say. Now, what if you had one like this? Okay, so if we go through and start to set it up, pretty much get the same thing, but what does that mean? What does 3 to the negative 5th mean?
You put it all over 1.
Yeah, you put it over 1, and that makes the exponent
Turn positive.
turn to positive. Right, so anytime you have a negative exponent, that means the 3 to the 5th would be in the bottom. So the answer to that is 1 over 243.
Okay. I don't know what
Okay.
side is like.
Let's look at graphing a log. Alright, so we've got y equals log, let's make something up, base 2 of x plus 3 minus 4. Because I didn't put every single possible thing in that you could have, but there's a few things. There's a couple shifts in it. Okay? First thing you want to do is find the vertical asymptote. So to find the vertical asymptote, set your argument equal to 0. Okay. So on my graph, I'm going to put a vertical line at -3. Usually I make it thinner, but I'm just going to go with that. Good enough. All right. Now, you should know in general how log functions look. Okay. All log functions, basically, if you don't reflect them, look like that. That would be your vertical asymptote. Okay. If you start flipping and reflecting it, you can make that log go the other way too. But there's no negative in the spot that would reflect it. There's no negative in front of x. There's no negative in front of the log. Okay. If there was a negative in front of one of the other numbers, you could also flip it so it goes like that. Okay. But in this case, you're not going to have to worry about any flips. All right, so let's plug in some values for x and just get the y values. Now, whenever you take the log, the argument has to be positive. So would I plug in numbers bigger than -3 or smaller?
Bigger.
Bigger. I have to plug in bigger. If I went smaller than -3, what I circled would come out negative, and you get imaginary answers. Okay, so let's pick, let's do 0. That's a good one. What's 0 plus 3? 3. So I need log base 3 of 2. That's exactly what we practiced right here, using the change of base formula. So let's figure out what that is. So log base 3 of 2.
So the base would be 3?
Oh
wait, never mind.
No, the base is 2.
Okay.
Log, I'm sorry if I said it wrong. We're on log base 2 of 3. Divided by log 2. And don't forget, you have to subtract 4. Okay, so if x is 0, you get -2.4. That's about right there. Let's do 5 and then 10. That'll be good enough. 5 plus 3 gives me 8, so I need log base 2 of 8, and then subtract 4. So log base 2 of 8, and subtract 4, that's going to be easy enough, gives me -1. 5, -1. And 10, what's 10 plus 3?
13.
So log base 2 of 13. And subtract 4. Okay, -0.3. All right, so we're at 10, just a little bit under. So remember, it's going to curve, and you can kind of see the curve a little bit from those dots. And that's what your graph will look like. Okay, so it's really the basic log function shifted down 4 units and shifted left 3. And that's how you graph a log function. Okay, any question on that? All right. All right, so let's look at a trig identity. let's try secant times cosine. So the trick that I explained to you guys in class was to change everything that's not a sine or a cosine into sine or cosine. So how can you rewrite secant? 1 over cosine. And cosine already is a sine over cosine. It's cosine. So I'm just going to leave that as cosine, but make it a fraction. And now we're going to multiply straight across. What's 1 times cosine? Cosine. And what's cosine times 1?
Cosine.
Cosine. And now we're dividing two things that are the same, and this is exactly the same as if you divided two numbers that were the same.
So just 1.
So you get 1. So the answer to that particular problem just comes out to 1. And that's it. Okay, any question on that? Okay, next thing that you want to know for the test is how to do a power model. Okay, any questions on the power model?
Is that the one typing in the calculator?
Yeah. All right, so we're going to find a power model. And we're going to use the data that's in the table right there. Okay, first thing you have to do is type the data in. So go to Stat, Edit. If you have stuff in L1 and L2, you can get rid of it. Otherwise, now you need to type it in. So 0, 1, 3. Okay, those are my x's. 0, 2, 54. Any questions on that part?
Wait, mine's on like L3.
Yours is on L3. Do you have an L1 and L2? If you scroll over to the left.
It's not moving, so I'm guessing no.
It's what?
It's like not moving over.
It's not moving over? Okay, let me take a look. All right, so now we've got our data typed in. Okay, next thing you want to do is bring your calculator back up on the screen. Okay, go to Stat. Calc, and the kind of model we're doing is a power regression. So if you go to option A, that's power regression. When you hit enter on it, if you're using one of my calculators, as long as you put your x's in L1 and your y's in L2, you just go to calculate. If you're using an older calculator, you might have to do something a little different. Did anyone not get that screen? You got it? Good, okay. So just go to calculate. And for the answer, we get
Mine did the same thing, mine did too.
domain. Okay, you know what? Take out the 0, 0 point. Just delete. Delete, that one messed it up. Now it should be okay. So just type in 1, 2.
How do I delete those?
Just press delete on the number.
It's not working.
This
What the
calculator
heck?
is too confusing for me.
Oh wait, it just worked. Sorry. Okay.
All right, so now with those, type in the same thing again. Stat, calc, power regression, and we created these from the equation 2x cubed. So we already know what we should get, hopefully. And that's exactly what I get. So to write your final answer, just fill in the numbers they give you. A is 2. X to the third power. That's how you find a power model. Question on that one? Okay. All right. So next thing, how to find trig functions on the calculator. So let's just say evaluate sine of 12. Can you tell me how I would type that in?
Just the sine button and 12.
Sine and 12.
In parentheses.
Okay.
And then don't you divide it by something?
No, not for sine.
Oh.
You don't have to do any division. That's it.
Oh.
So the sine of 12 is negative 0.54, roughly. Okay, how about the tangent of 62 degrees? How would I take that one in?
That one you have to
Don't you divide it by, don't you divide something in this one?
180 on the bottom and the pi on top?
No, you don't have to.
It doesn't matter that it's a degree.
It does matter that it's a degree, though.
Do you have
Yes.
to multiply it?
I don't know.
Well, what else could I do besides converting this to radians? What could I change in my calculator?
Oh yeah, you have to put it to degree.
Change the mode of the calculator to degrees. That way you don't have to convert anything by hand. And now you're ready to type it in. Tangent 62. Had you not changed that mode, you would have gotten it wrong. Okay, so just change the mode. You should get about 1.8 again. Okay, how about the cosecant of 19 degrees? Do we have a button that says CSC?
No.
No.
So is this the one you divide?
This one you have to use a fraction. Yep.
So do you do
So I was find the
1
points of
over sine
Mm-hmm.
and then 19?
Exactly. To find cosecant, you take the sine and flip it. So that one is about 3.07. Any questions on that? Okay, what else do we do next? Arc length. So let's find the arc length. Okay, so let's say the radius was 20 inches and the angle was 40 degrees. Okay, so do you want to visualize what's happening here? You have a 40-degree angle inside a circle, and the radius is 20 inches. Bless you. I want to know how long that arc in green is. Okay, so what's our formula for length of an arc?
S equals R.
R theta. And are the numbers they gave me ready to plug into that?
No.
No. Something has to be fixed. What do we have to fix there?
40 degrees.
What do you have to do with it?
Do you divide it by, oh no, multiply it.
Multiply by
Pi
pi
over 180.
over 180. If you want, you could, just to reduce that, make it a little smaller. So we've got 4 pi over 18. That's your angle. Okay, what was the radius?
Oh, it's 4 pi over 18?
That's the angle, 4 pi over 18.
The radius was 20.
The radius is 20. And the angle is 4 pi over 18. Now I know you can reduce 4 pi over 18 more, but I would just type it into the calculator. And then just round it off. So we're going to have, if you want to reduce, it's up to you. 20 times 2 is 40. 40 times pi, and then divide by 9. Do you have what that comes out to, Mina?
I don't know if I did it right.
Wait, I'll tell you. Give me 1 second.
Well, 40 times 3, which is a little off, would be about 60 divided by 9. 60 divided by 9 is about 5.
I got 13.9.
6, 7.
6.
13.9.
6.
Did I just go wrong?
Did you get that too?
Yeah.
Oh, you know what? Yeah, I'm sorry. I did 20 times 3. I meant to do 40 times 3 is 120 divided by 9, roughly. So let me just check quick. I got about that, but that's a little off. What did you get?
13.96.
Yeah, that's right. And that's an arc length, and in this problem,
Inches.
lengths were inches. Okay, so that could be set up to solve for the length of the arc, the length of the radius, or the angle. But they'll always give you two things. right. Right, so let's get a unit circle problem. Okay, so let's say you had the coordinate 1/2 root 3 over 2, and I asked you to tell me the cosine of the angle represented by that coordinate. What would the cosine be?
Wait. Oh, it would be 1/2.
1/2. Now from today, I know you probably remember, this has something to do with either a 30 or a 60 degree angle.
Yeah.
I don't really care, that doesn't matter. All I need to know is the coordinate, and they gave it to me. How about the tangent? What's the formula for tangent?
Y over x.
Y divided by x. So when you divide those,
Square root of 3.
2's cancel, and you get the square root of 3.
Are we gonna have to know like the triangles, like the 60 degree,
30, 60,
30? Are we gonna need to know that for the test?
Yeah, you should know, like, let's say I gave you a problem like, find the sine of 210. Now, what are you missing here that you need to do that?
The intercept? The things?
The coordinate.
The
That's what I
coordinate.
meant. That's what I meant.
Yeah.
I don't know why I said that. I don't know why I said that. That's legit what I meant. I swear.
Alright, so roughly, if I'm going to sketch that, where's 210?
Like a third past 180.
Yeah, it's 30 degrees past 180.
So is it a 30 degree triangle?
Yeah, because it's 30 degrees past 180, it's the 30, 60, 90 triangle. This is the short side. That's the long side. What's the length of the short side in the 30, 60, 90 triangle?
Half.
Yep, it's a half. And what's the length of the long side?
Square root of 3 over 2.
And now, because we're in quadrant 3, we went left and we went down, both of those numbers would be
Negative.
negative.
Didn't we do this in trig?
Yes. Yep. So x is negative root 3 over 2. Y is negative a half. Now specifically they asked for the sine.
So it would just be y.
So the sine is just the y, which would be
Negative.
negative a half. So it's a lot easier if they give you the coordinate. If they don't, that's how you do it. Tell me an angle that would be coterminal with 210.
570.
How'd you get that?
Add 360.
Yeah, if you add 360, what did you say, 570?
Yeah.
How about another one that's negative?
Negative 150. No, wait. That did not work out.
Negative 150. Yeah.
Negative
Oh,
150.
that's right.
So if you add or subtract 360, you can get angles that are coterminal.
What about, what's the other one called? When you like, never mind actually. I don't know what I was just thinking.
All right, and the last one. This has to do with angular velocity. So let's say we have a car tire. And the car tire rolls 840 degrees. I need to tell you the size of the tire. So let's say the radius of the tire is, let's say 10 inches. So the radius is 10 inches. How far did the tire roll? Okay, what do you think you're going to have to find here to do that? Yeah, you're going to need the circumference of the tire because you're trying to figure out how far it rolled. Well, if here's the tire, pretend like that was a piece of metal in a circle. If you cut it right there and then straightened it out, you could figure out the length of one revolution. So the way we do that with the formula is use circumference. So circumference equals what? 2 pi r. Okay, so circumference equals 2 pi times 10. Now what if they had given you a diameter? What would you have done to change it to radius?
Divided it by 2.
Right, so be very careful in the problem whether they say the diameter is the number or the radius. Okay, so what's the circumference?
I got 62.83.
62.83?
83.
Okay. Now that's how many inches, what is that? How many inches in one revolution, which is one circumference of the wheel. So we have to figure out how many revolutions the wheel is making. Is it just going one revolution?
Oh no.
No, it's doing more than that. It's 840 degrees. So I want to convert degrees to revolutions.
So
Where would degrees go to cancel out?
the bottom.
How many degrees in a revolution?
180. Oh, what?
360.
360. Okay, so take 840, divide by 360. The tire is making 2 1/3 revolutions. So that's how much it would roll in one revolution. That's how many revolutions the tire is making. So what would you do with the two numbers?
Times them.
Times them. So we're doing 62.83 inches for one revolution, but we're doing 2.33 revolutions. So the tire is going to roll 146.4 inches.